Hello everyone, in this video we'll be solving problem 100, same tree. Given the roots of two binary trees P and Q, write a function to check if they are same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. Looking at example number 1, if you check for each node at each step, they all are same. So the output will be true. Number 2, we have the parent node same, but the node 2 is on the left side of P, but it is on the right side for Q. So they are kind of mirror or symmetric. So we will return false. Similarly, for example number 3, they are mirror because 2 is on the left hand side, but 2 for the second node for the second tree is on the right hand side. So this will also be false. This is a very easy problem as long as you understand how to traverse through a binary tree using a BFS or a DFS approach. So let's quickly switch to whiteboard and discuss how we can solve this problem. We could either use a DFS approach or a BFS approach to solve this problem. Both of them will be efficient in solving it, but today we'll use the BFS approach or breadth first search approach. We'll use two pointers. One will be pointing at P and the other will be pointing at Q, and at every depth we'll compare values at each node and iterate further. If we are going to the left side for P, we'll do the same for Q as well. So starting with the first pointer pointing at 1 for the P and the other pointing at this node on the right hand side. Are the values equal? Yes. So we'll go to the left hand side for both of the nodes. We'll do the same checks. We'll check if these values are equal. Yes, they are. As the values are equal, we'll go deeper. We'll check the next node on the left hand side, which is 4 for P and also 4 for Q. So which is still equal as there are no more nodes after that. So we'll go up. We'll check if there are any right legs for 2. If yes, then we'll check. If no, then we'll continue forward. If any of one particular node have a right leg but the other one does not, that also is a sign that the two trees are not equal, so we'll return false. But that's not the case in this example, so we'll move up to 1 and then go to the right hand side. When we are at 3, we'll check if 3 is equal. Yes, so we'll move further. We'll go down to 5. Is 5 equal? Yes, it is also on the left hand side of node 3. So far we have not found any differences between the two trees. So our output will be true. Let's say if we had a new node over here. So when we were checking node 2, the parent node is equal, but on the right hand side there is no nodes for P, but we have one for Q. So in this case, we would have returned false and halted the iteration. The time complexity of this solution is O of n, where n is the number of nodes in the binary tree. And the space complexity is O of 1, as we are not saving anything into any variable, simply returning false if we encounter a difference. I hope you were able to understand this solution. Let me show you how we can implement this using C#. So here's the main method where we are getting P and Q as the input. I start by checking if both P and Q are null. If they are, then I'm simply returning true. If Q is null but P is not, which means there is a difference, or if Q is not null and P is null. So in this case, we are returning false. The other case to check is if the values of P and Q are not equal. In that case, we are also returning false. If none of these cases are met, then we are calling the same method is same tree, but passing the left P and left Q. And if this returns true, then we are calling the same method, but passing the right side of the binary tree. If both of these methods or iterations returns true, then we are returning true in this method. And if not, then we return false. This solution, when submitted on LeetCode, beats 100% of the submissions in terms of runtime complexity so far, and In terms of memory consumption or space utilization, it beats 48% of the submissions. Thank you for watching this video. I hope you were able to understand this solution and my explanation. The link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.